I love playing video games. The feeling of progressing from one level to another and getting stronger or better at the game, I think is one of the best feelings in the world. In the same way, there are 6 levels of thinking for math, where each level is tied to a unique set of skills and success criteria. This concept actually came from a learning theory called Bloom's taxonomy, which I adapted to fit into the context of learning math. In this video, I'm gonna go through all 6 levels along with examples as well as my top secret method to help you ace your next math exam. So let us begin at level 1, which is called identifying topics and remembering formulas. A student at level 1 should be able to identify which topic a question is and write down at least one of the formulas that they have remembered. A student at level 1 has absolutely no clue what the formula does or how to apply it. So let's take a look at a few examples of level 1 thinking from set 1 to set 4 math. In order to reach level 1, we just have to identify which topic these questions are asking from. So this is a number pattern question, this one is on algebraic expansions, this one is on quadratic factorization, and this is on the area of a sector. And if we are lucky, we manage to remember some of the formulas and just write it down, but unfortunately our journey ends here. Okay, let's not kid ourselves. These are basically the students that just started studying the night before the exam, or have absolutely no idea what's going on. The most common bad advice that people give for math is just to memorize formulas. But just memorizing doesn't get you very far in terms of the question, and the result that you'll probably get is somewhere around 0 to 20%. But you know what they say, the F students are inventors! Level 2 is about being able to know what the formula does. To reach level 2, you should be able to understand and explain what each variable in the formula is referring to and identify the corresponding information given in the question. The jump from level 1 to 2 is actually not that big and can be easily achieved by practicing 1 or 2 questions. Even though someone at level 2 knows what formulas should be used for basic questions, they may still not know how to fully solve a question yet. A level 2 response sees a step up from the previous one where we know what each variable in the equation represents. For this number pattern question, A represents the first term of the number pattern, and D represents the common difference between the consecutive terms. Also, we know that N refers to what term it is, and Tn is what you get out of the number pattern. For an algebraic expansion, we know that A and B can represent whatever, and the values of A and B have to be substituted into the right-hand side of this equation over here. For a quadratic, there's the really long quadratic formula where A, B, and C are the coefficients, which is one method. And we recall there is also another mysterious way to turn a quadratic equation like this into the x minus A and x minus B form, where we have to find out what A and B actually is. Level 2 is where you sort of get the hang of what to do, but haven't actually executed the steps correctly on your own yet. I don't know how many of y'all are rock climbers that are watching this, but it's kind of like watching someone else complete a climb and you know what steps and moves they did, but you haven't actually tried climbing it yet, and then you fail miserably. The main thing that holds students back at level 2 is the lack of practice. Most students kind of know what they're supposed to do or what formula to use, but are not able to successfully execute the steps most of the time. So this leads to a score of somewhere from 20 to 50% depending on luck and depending on if they're able to execute those steps. Level 3 is where most students are at after some practice, which is the ability to apply and execute in order to solve standard questions. At level 3, you can solve what I like to call one-to-one problems, where one concept is required to solve one problem. Level 3 is all about doing practice questions so that when you look at routine questions, you instantly know what method to apply and how to carry it out. Students usually achieve level 3 by following what their teacher says and doing some practice problems. In fact, level 3 is where I would recommend students to start from, solving and practicing problems. Instead of reading through notes or blindly memorizing formulas, you can start by solving practice problems and fill in your knowledge gaps by extracting out the formulas that you need from your textbook or notes. Essentially, you start practicing problems and think at level 3, and your brain will automatically fill in level 1 and 2 for you. For a number pattern question like this, step 1 is to find out the first term, which is 3, and the common difference, which is 4. Step 2 is to apply the formula Tn is equals to A plus n minus 1 times D, where we substitute 3 and 4 inside, which gives us the general formula of Tn to be equals to 4n minus 1. Finally, the last step is, since that's the 50th term, it means that n is equals to 50, so we can sub that into the general formula to get 199. In order to expand this, step 1 is to recall and identify the correct algebraic identity, which is that a minus b squared is equals to a squared minus 2ab plus b squared. Step 2 is to identify what is our a and b values, so we can notice that a is equals to 3x and b is equals to 4y. Step 3 is to apply the formula by substituting the values of a and b inside the equation, and the final step is to expand these brackets out and simplifying to get our final answer. Going on the theme of following a list of procedural steps, to factorize a quadratic, step 1 is to draw the multiplication frame and put in the coefficients of the x squared and the constant term over here. Step 2 is to find a combination where this and this will multiply to 2x squared, as well as this and this will multiply to negative 30. And we have to verify that the sum of these two boxes will give you the x term, which is 4x. Step 3 is to write out the factors here and use the zero product rule to solve for the values of x. Because this question gives us a sector and a triangle, so step 1 is to recall the formula that the area of the sector is half r squared theta, and we substitute the value of theta to be 2.2 radians. Next, the formula of the area of the triangle is half AB sine C, where C is the included angle here, so we can substitute C is equals to 2.2 radians. Step 3 is to calculate the shaded area in terms of R, and step 4 is to apply the percentage change formula to compare the shaded area to the entire circle. As you can see, one-to-one problems are all about knowing and applying a certain procedure correctly. When similar problems show up where the numbers are different, students that think at level 3 will be able to solve these steps correctly. Level 3 is where most of the student population is at, getting anywhere from 50 to 65% provided that they make minimal careless mistakes. They can get most of the standard questions correct, but get stuck when things get unfamiliar. But you want to achieve greatness, so you have to move higher. Level 4 thinking and onwards is all about higher order learning. The key difference for level 4 is the ability to analyze and solve problems that are asked in reverse order. A very common way that exam setters make familiar problems unfamiliar is to pull the Uno reverse card and ask the questions in reverse. It becomes more difficult because now it's not so obvious which formula you have to use, and you have to think about how to apply this formula but in reverse. To reach level 4, allow me to let you in on a study tip which I call the Pokédex strategy. You know how in Pokemon, each time you encounter a new Pokemon, it gets added into your Pokédex? So each time you encounter a new question type, archive it corresponding to the chapter and the subtopic where it's located at. This way it makes revising for exams way easier, because at one glance you can see all the different question types that you have encountered. So let's take a look at some examples of the level 4 questions that can be asked in reverse. Notice that this number pattern here is asked in reverse, where instead of giving you the sequence, they ask you to find the common difference. So given that the 50th term is negative 45, we know that the common difference D is negative. So putting the values of A is equals to 53 and the term of 50 equals to negative 45, we can solve for the common difference D is equals to negative 2, which allows us to find the X, Y, and Z values of 51, 49, and 47. Instead of asking us to expand the algebraic identity, this question works kind of like a jigsaw puzzle, where we have to make a smart guess on which identity to use to factorize 2x squared minus 2y squared. Notice that if we try x minus y squared, there's too many unknowns, so that's not correct. But if we use the algebraic identity of x squared minus y squared, we notice that we have x minus y and we want to find x plus y, and that if we factorize a 2 out, we can achieve x squared minus y squared, which gives us 125 over 2. So by referring to our identity here, we can get x plus y is equals to 25. This is quite a challenging question where we have to construct back a quadratic equation in the form of y is equals to ax squared plus bx plus c. Since negative 2 and 1 are the factors, we know that the two products are x plus 2 and x minus 1, multiplied by some constant k because we don't know the coefficient of x squared. Since the question states that it has a y-intercept of -4, we can sub in x is equals to 0 and y is equals to -4 to solve for k is equals to 2. So after expanding it, we have our final quadratic equation here. Students that are thinking at level 4 are your above average students, and you can get to level 4 by consistent practice and being deliberate about identifying different question types. When completing a question, a pro tip is to ask yourself, how can this question be asked in reverse? And really think about it before moving on. This way, you are more prepared for the Uno reverse card when it actually shows up in the future. Students that are level 4 get around 65 to 80% and can usually solve most standard questions and some higher order questions. But do you want to be a true math genius? Level 5 is where all the top math students are at, and the key common trait they all have is the ability to solve higher order thinking questions. Students who think at level 5 know how to solve questions using different methods and have a deep understanding of various topics. They are able to understand one concept in many different ways and constantly challenge their assumptions on whether they are right or wrong, and that's what makes them so good at math. So when they're thrown these unfamiliar questions, they're able to evaluate which method is the most suitable or has the highest chance of working out. These higher order thinking questions come in two forms, the first being questions that are asked in a unique or unfamiliar context, and the second are the topics crossover kind, where there are multiple topics and concepts that are morphed together and tested in one single question. Let's take a look at this question here, and from the first glance, it's not obvious which topic this is. Maybe it's something about circles, and maybe you can draw a sector like this. So the first step is to actually let the radius be r and mark it out here, here, and here. Next, we can notice that this length over here has a length of r minus 3, and here is r minus 6, which forms a right-angled triangle like this. So we can use the Pythagoras theorem to construct an equation, and after expanding it out, we can solve for the quadratic where we get r is equals to 15 or r is equals to 3. And since this length is already 3, we know we have to reject the value of r is equals to 3. This is probably one of the most difficult O-level questions where again the context is unfamiliar. So let's try to turn this hexagon into triangles so that we can compare the two shapes by slicing this hexagon into 6 equilateral triangles. So looking at the ratio of the perimeters, if one side of the hexagon is x, we can do 6x times 2 divided by 3 sides of this bigger triangle to get 4x. Then we can apply the ratio of similar shapes to get the area of one small triangle to the big triangle to be 1:16. Then since the hexagon is made up of 6 of these triangles, the final answer is 6/16. Even though this is not a real O-level question, it's the perfect example of different topics mixed together in this Frankenstein monster of a question. The first step is to complete the square in order to transform the equation into the standard form of our circle equation. We can see that the center is 2k and 2, while the value of r squared is this cubic polynomial over here. Since r squared has to be greater than 0, we need to try to factorize this cubic polynomial p of x, so we start guessing a factor. So let's try to sub k is equals to 1, and calculating we get p of 1 is equals to 0, so we know that k minus 1 is a factor. After performing long division and further factorizing this quadratic over here, we can get the full factorization of p of x. The last step is to identify the roots of the polynomial to be -4, -1, and 1. And since the coefficient of k cubed is positive, the graph looks something like this. Therefore, the region that is greater than 0 is the values of k in between -4 and -1, or k is greater than 1. Students who think at level 5 are like the students in your school that you go to if you need help with your math homework, and they always seem to know how to do it. They can think of out-of-the-box solutions to many questions because of the experience they have doing so many different types of problems and constantly trying out different methods to challenge themselves. They usually score around 80 to 95% and are the ones that compete in those math Olympiads and go up on stage to receive math-related awards. If you are at level 4 attempting to reach level 5, you've probably done your fair bit of practice questions, so let me teach you a strategy that I use to 10 times my studying efficiency. But you have to promise me that you won't cheat yourself by doing this, okay? Because it can easily backfire if done wrongly. And the strategy is to practice doing questions by not actually doing them. Okay, let me explain. Typically, students study math by attempting an exam paper and doing every single question before marking their work, and this is called time practice. While this is good, at level 5, we really want to target exposure to unfamiliar question types and spending more time on those. At each question, I would take a look and think of the method to solve it. Then I would check the answer key to check if my method was correct. If I got it correct, then I would move on. Only when I can't think of the method or when I got the method wrong, then I will actually attempt and work out the full question before looking at the answers. I would then add these questions to my Pokédex notebook thingy. Because at this stage, we've already got our procedural steps down, so we don't have to waste time doing standard questions over and over. Essentially, while it takes other people 2 hours to do a full paper, with this method, it only takes us 20 minutes because we are focusing our efforts on challenging unfamiliar questions. Level 6 is where you have truly ascended and at the highest level of thinking. And the key skill that demonstrates level 6 thinking is to be able to create and set original questions for a specific purpose. Being able to set original questions takes way more thinking than people give it credit for. And most of the time when I come up with questions, I learn about things that I never thought existed before. Someone who thinks at level 6 can set an original question from levels 3, 4, and 5 given a specific prompt. Okay, let me show you what goes behind setting a question. Let's consider this question where we know we have to combine this fraction together in order to solve it, multiply both sides by x minus 1 times x minus 3, expanding it out, and solve for the quadratic to get the solution. Solving it is easy enough, but setting one is not so easy. What if we wanted to get a similar question that tests this same concept, but we want the final answer to be x is equal to 7 and x is equal to negative 1? So first we have to set the products to be 0 and expand it out. Next we have to consider another quadratic 2 factors, which are going to be our denominator for our fractions here. So in order to make it simple, we go with x plus 3 times x minus 2. Next, we have to split up our original quadratic such that the right hand side are the roots of the new quadratic and the left hand sides we get 7x plus 1. In this 7x plus 1, we now need to find a and b such that there's a combination of something times x minus 3 and something times x minus 2 that will give us 7x plus 1. So after some trial and error, we get a nice whole number of 3 times x plus 3 and 4 times x minus 2. And notice if we divide both sides by the product of the two factors, we can get the right hand side of 1 and split aside the left hand side into 2 fractions. Let me show you what goes through my head when I want to set a question with a certain context. I love the Genshin TCG card game, so recently I bought a real life version of the Genshin TCG dice and I thought to myself, wait, I can totally turn this into a math question. So this is an 8-sided dice, and I could see that it's made up of 2 pyramids joined together. So let's make the goal of the question to find the volume of this dice, which is 1/3 times the base area times the height, multiplied by 2 because there are 2 pyramids. Instead of just giving the height, let's try to make the solver calculate it. So we make this our unknown. The dice looks like all the faces are an equilateral triangle, so I'm trying to figure out the minimum amount of information we have to give in order to calculate the height. If each face is an equilateral triangle of side 3 cm, we try to test it out and see if we can actually find the vertical height. If we examine each face of the triangle, there's 2 methods to find the slant height L. One being Pythagoras theorem, since this here is 1.5 cm, and another using trigonometry, since this angle is 60 degrees. Now using the slant height, we can calculate the vertical height h by drawing out another right-angled triangle here and doing the Pythagoras theorem again, and then we can finally get the volume of 12.7 cm3. As a bonus, I like to think of extension questions, like for example, what topic can I merge this with? And for this question, I think it has good potential to be a problem in real-world context question, where you're given the price of the material in per kg and the density, and you have to calculate the cost. Another route I can see this question going is the similar solids route, where with another similar dice of maybe side 5 cm in length, we can use the ratio of the volumes formula. Let's take a look at this other question I came up with, where my intention was to create a logarithm question where the base is the unknown and you have to solve for the base. So I kind of created this question by working backwards, where I started with something like this and then progressively added more concepts to apply. Next, I wanted to split up this 36 into 2, 3, and 6 to test the logarithm laws that adding up of the logs of the same base will make it multiplied. Then after that, I wanted to throw in a change of base, so I added in a reciprocal, and you can only solve for it if you change each logarithm to base x. So after working out the solution, changing the base, cancelling out the log xx is equals to 1, and combining the logs, we can solve for x squared to be equals to 36. And we can get x is equals to 6, and x is equals to negative 6, which we have to reject since the logs can't be negative. Not many students have level 6 thinking because this level is usually reserved for teachers and textbook writers which already have years of experience doing, teaching, and setting a wide variety of questions. Someone who thinks that level 6 is truly a master of the syllabus and will score close to 100%. Whatever questions that are thrown at them, they have either seen it before or have thought of a variation of it before. If you are a student, you don't have to worry too much about reaching level 6 to get the A, but I hope you found a newfound appreciation behind the work that goes into setting questions. And that is it! From level 1 to level 6, these are all the levels of thinking as you progress from one to another to get better at math. Unless you're an absolute genius, everyone starts off at the lower levels and works their way up through consistent practice and being intentional about wanting to become better. And that is truly the fun of learning math. Not the grades or whatever, but to write that easy game at the end of your paper after solving it. Take care everyone, Axolotl out!